Why does no one dare to admit that Oumuamua is actually alien technology? Some of its phenomena seem to defy all known laws of physics. Scientists say it is not a comet, not an asteroid, and it might not even be naturally formed. So what exactly is it? Why does every explanation seem like it is avoiding a more dangerous truth? In the journey ahead, we won't talk about mysticism, we will only talk about evidence, all in pursuit of a more accurate answer. But to truly understand the shock Oumuamua brought, we have to turn back time to the moment it first appeared. Was October 19th. 2017, Hawaii's Pan-STARRS 1 telescope captured its image. At first, scientists thought it was an ordinary comet, and named it C2017 DO, but strangely, it actually did not have a comma, and it did not have a tail. A few days later, it was reclassified as an asteroid, designation 2017 DO, but as the calculations went deeper, they discovered this thing was traveling on a hyperbolic trajectory. In other words, it is not orbiting the sun. Instead, it is accelerating away from the entire solar system. So scientists had to create a whole new category for it. It was officially named Oumuamua. This was the first time in human history that this had happened, to witness with our own eyes a visitor from interstellar space. This name comes from the Hawaiian language. It means a messenger from afar, arriving first. On one hand, it is a tribute to the telescope that discovered it. On the other hand, it also hints at its unique status as a forerunner, and from the very first second it appeared, something just felt off. Its speed is too fast, the trajectory is too strange, no matter how you look at it. It does not seem like an old acquaintance from the solar system. Instead, it looks more like an intruder. It made a brief pass by the sun. It even entered inside Mercury's orbit. There, its speed reached an astonishing 54 meters per second. Then it was slingshotted away by the sun's gravity. It flew straight into interstellar space. Without looking back, astronomers around the world raced to observe its behavior. Within just a few short weeks, as it tumbled through space, people were amazed to discover that its brightness fluctuated wildly. It was as if an unusually long, even flat object was spinning. Early estimates suggested it could be as long as 400 meters, with an aspect ratio as high as 10, like a giant space cigar floating through the cosmos. But further light curve analysis raised another possibility. It might actually resemble a space pancake, with a ratio between 6.1 and 6.6. No matter which shape it is unlike any comet we have ever seen, or asteroid. It is not very large, only a few hundred feet wide. Its surface is deep red, which is most likely the result of long-term exposure to high-energy particles as it wandered through space. But the most difficult thing to accept is, it does not have any of the gases a comet should have, or any trace of dust. Astronomer Karen Meach once said, even if it were passing right by the sun, no matter how powerful our telescopes are, we still would not see even a hint of dust on it. The mystery was only beginning. Its trajectory could not be fully explained by gravity alone. As it moved away from the sun, it showed a faint non-gravitational acceleration, as if someone had gently pushed it from behind. Normally, jets from comets cause this kind of phenomenon, but with Oumuamua, not a trace of Gay was detected. This threw the entire scientific community into confusion. An object without a tail. What exactly is this celestial body that is accelerating without any jets? Is it releasing some kind of substance that we simply can't see, or is it not a naturally occurring object at all? The public quickly began to speculate. Could it be an alien spacecraft disguised as a celestial body? And scientists, although most still lean toward natural explanations, every one of their hypotheses sounds rather implausible or even self-contradictory. We only know one thing. Oumuamua did come. But what was it? Why did it come? No one can give a definite answer. To solve the mystery of Oumuamua's invisible acceleration, in 2020, two scientists proposed a very bold hypothesis. Daryl Seligman and Gregory Laughlin believe that the true nature of Oumuamua might not be rock, metal, or at all, but rather, it is made of an extremely rare substance, molecular ice. Their hypothesis goes like this. In the distant depths of the universe, there are regions called giant molecular clouds. The temperature there is close to absolute zero. Celestial bodies similar to light icebergs might form there. This light ice sublimates when it approaches the sun, changing directly from solid to gas. It does not even require a very high temperature, and this kind of sublimation is not like the explosive jets of ordinary stars. It is a uniform, quiet, almost invisible release. It is as if the entire surface of the object is lined with a ring of tiny invisible thrusters. Because pure hydrogen is almost undetectable, invisible and infrared light, it does not emit light, nor does it leave behind any tail or debris. So from its appearance, it looks like an asteroid, but judging by its trajectory, it is more like a disguised substitute star. This model is truly ingenious. It explains the two biggest problems at once. Why did not it evaporate? And why is it accelerating? Moreover, it can even explain Oumuamua's strange shape. The two scientists pointed out that continuous sublimation of pure ice would cause the celestial body to gradually lose mass. Its edges would erode, and its overall proportions would become elongated. This might explain why it is so elongated, like a cosmic cigar. They also emphasized that this kind of light icy body can only form in extremely cold and dense interstellar environments, for example, in the core of a dark molecular cloud, where the temperature is close to 3 Kelvin, that is about as close to absolute zero as you can get. If Oumuamua really set sail from there, then it is not surprising that it drifted through interstellar space for hundreds of millions of years. It is nothing unusual, and during this journey, it was gradually eroded by cosmic rays along the way, until it quietly entered our field of view. The scenario is truly fascinating, a primordial iceberg drifting in from the cold, distant edge of the universe, no tail, no sound, yet it carries a journey of billions of years. But this hypothesis quickly sparked intense controversy in the scientific community. Later that same year, Hong Qiangxing and Yue Lebu published a rebuttal paper. They believe this King Bing theory sounds sophisticated, but it simply does not hold up. The first problem they point out is starlight. In the Milky Way, even the faintest starlight, shining over many years, would be enough to gradually heat up and evaporate the King Bing. Their calculations show hydrogen iceberg the size of Oumuamua would completely evaporate within 10 million years, but Oumuamua's trajectory suggests it could be over 100 million years old. Based on this alone, the hydrogen iceberg model is already self-contradictory. Even more seriously, Oumuamua, if it really came from a dense molecular cloud core, then during its departure, it would inevitably pass through large amounts of gas and dust. These collisions would make it evaporate even faster, so it would not have survived until today. But the most fatal rebuttal is yet to come. Ong Hilibu pointed out that something like a pure ice block might not even be able to form at all, because the original particles of pure ice are extremely unstable before they even have a chance to merge into an iceberg. They are disturbed by starlight and heat and disperse prematurely. The conclusion is straightforward and also harsh. A body of pure ice could never drift here from deep space, let alone travel through the solar system. Completely intact, he should have melted on the way, like a snowflake in the universe. This debate is what real science looks like. It is not about who is right or wrong. It is a way of pushing the truth forward through constant rebuttal. And now, the question has returned to the starting point. If it is not light ice, then what is it? In this cycle of hypothesis and refutation, the scientific community welcomed a new idea. This is also the clue we will be talking about next. After the old hypothesis was overturned, a new explanation finally surfaced in 2023, and this time, he made many scientists nod in agreement. This time, the hypothesis was proposed by chemist Jennifer Bergner, and that familiar name, Dara Seligman. They teamed up once again and presented a possibility that seems even more realistic. Oumuamua might not be made of any rare element at all. It is just a very ordinary frozen celestial body. It is more like a fragment of a quasar. But during its 10,000-year drift through the universe, some unexpected changes occurred. Here's what they proposed. This water ice-rich celestial body constantly encountered cosmic ray bombardment as it traveled through interstellar space. These high-energy particles can penetrate deep into the ice. There, they trigger subtle but real chemical reactions. In the laboratory, we know that when water ice is irradiated, some of the molecules break apart, forming molecular hydrogen, which quietly becomes trapped within the structure of the ice. This hydrogen does not escape, but gets trapped in amorphous water ice, hidden within the ice as tiny bubbles. Millions of years pass. Inside this celestial body, a considerable reservoir of hydrogen quietly accumulates, until 2017, when Oumuamua entered the solar system for the first time, flying toward the sun. Come on, it starts to warm up, but not with intense heating. Its surface temperature never gets high enough to melt water ice. No water vapor has been detected in any observations, but this slight warmth is enough to awaken the dormant energy inside it. As the temperature rises, the water ice begins to recrystallize. The structure of the ice is rearranged. The hydrogen trapped in the system is also released as a result. This process is gentle and stable, yet it produces a slow and continuous thrust. Bergner and Seligman calculated and found as long as this celestial body releases tens to hundreds of grams of hydrogen per second, that is enough to cause the non-gravitational acceleration we have observed. And what is even more remarkable is that this release process is completely silent. Hydrogen is extremely light and very stable. It does not emit light or reflect. No tail. Nothing glowing. Even if there is dust mixed in the ice, those particles would be trapped inside the ice. They would not fly out at all, so you end up with a kind of thrust but with no visible trace of propulsion. It almost sounds like an invisible engine. This is an extremely elegant explanation. Ordinary water ice combined with cosmic rays produces invisible hydrogen gas. Add a bit of the sun's heat, and you can trigger an almost undetectable propulsion mechanism. It does not require exotic matter, nor does it need complex conditions. It also perfectly matches everything we know about Oumuamua. All its characteristics: a dark red surface, consistent with a remnant that has undergone long-term space weathering. No gases detected. Compensize. Non-gravitational acceleration along its trajectory, all of which can be accounted for. In the end, Bergner and Seligman came to this conclusion. Oumuamua is most likely, in essence, just an ordinary quasar-like object. It simply slept too long at the frozen edge of the universe, and during that long drift, it quietly accumulated a reservoir of hydrogen in its icy layers. When it was awakened by sunlight, he began that invisible escape. He had no dazzling tail, no visible reaction, but performed a true act of disguise through his actions. The reason the Planet 9 hypothesis quickly became popular is that it pieced together all the scattered clues, without needing alien spaceships, advanced technology, or exotic matter. Such a strange phenomenon can actually be explained in the end by something so simple, elegant, and unconvincing. This explanation also leaves us with a warning. Sometimes, the things that seem most mysterious may just be us misreading their silence. And Oumuamua's story might be just like that. Instead, it reminds us not to judge by appearances. Do not rush to conclusions. While we are still debating what Oumuamua actually is, there is another, deeper question that no one has truly answered. Where did it come from? Right now, when it comes to its origin, we still have only a few vague clues. But scientists have already proposed several plausible hypotheses. As early as 2018, astronomers tried to trace its trajectory backwards. The results showed it may have been drifting through the galaxy for hundreds of millions of years, until, by chance, it happened to pass near our Sun. His flight path came from the direction of Lyra. He was approaching the region where Vega is located. But the problem is, by the time he actually passed by, Vega was no longer in that position. Because he had been flying for so long, even the positions of the stars had changed. So how did he leave his own star system? The mainstream view is that it was most likely ejected from a young stellar system during planet formation, kicked out in a gravitational tussle. In the early stages of a planetary system, newborn celestial bodies often collide and compete for position, and those massive giants act like gravitational slingshots. It can fling small celestial bodies right out of the entire system, sending them speeding into interstellar space. In fact, our own solar system is the same. Giants like Jupiter and Saturn may have already flung trillions of planetesimal-like bodies far away. That is how our distant Oort cloud was formed. As for Oumuamua's home, it may have gone through a similar experience. One or more rogue giant planets acted like cannons in the universe and flung it into a long journey through space. There is another possibility. It may have come from a binary star system. Some studies suggest that such binary star systems, in their early stages of formation, it is especially unstable. It is particularly easy for celestial bodies to be ejected. And another, even bolder, hypothesis is that Oumuamua might not have been thrown out. Perhaps it was originally part of an exoplanet similar to Pluto, just a fragment, mainly composed of nitrogen ice. As a result, it was shattered by a violent impact. He was one of the fragments that flew out. Interestingly, this theory also tries to use sublimation to explain Oumuamua's acceleration. But this hypothesis has even more problems than the hydrogen model. Currently, the mainstream scientific community believes its credibility. It is far lower than the mechanism where water ice releases hydrogen. Now it is more than 40 astronomical units away from the Sun. That is 40 times the distance between the Earth and the Sun. It has gone far beyond Pluto, and it is still accelerating away. Now we are trying to shift from being passive to being proactive, from waiting for miracles to creating opportunities. The next time a messenger from a distant star system arrives, flying into the solar system, we may no longer have to just look up and regret missing it. Instead, we can reach out and get closer to it. Question is no longer whether we'll encounter Oumuamua again, but when we will meet the next one. And every interstellar visitor could bring an awakening that goes beyond Earth. A journey that breaks boundaries, an in-depth conversation about the nature of the universe. We do not know where they come from, nor do we know where they will take us. But there is one thing we can finally be sure of. That unfamiliar star breaks into our sky again next time. We will be ready to welcome it.